I'm so excited to be here. And before I start this presentation, I want to sort of pinpoint why this is so important to me. DPC has been an event that I've been attending since 2008. So who's been around for that long? I see some familiar faces here. Yeah, a couple. Welcome back. So for me, it's been a huge event because it changed a lot in my career. And as a struggling speaker back in 2008, I knew attending events like this, I wanted to be part of this. I wanted to stand here right where I'm standing, but no one gave me the opportunity because no one knew me. So I slugged it out in the underground, right, doing what you're supposed to be doing, going to meetups, getting to know people, being part of the community. And it was in 2010 that the DPC organizers gave me my very first shot at an international speaking engagement. And I was excited, and I delivered. And what happened afterwards is all the other events I tried to submit to, all of a sudden I was considered safe because DPC scheduled me. And I have developed a speaking career, and I owe a great deal of gratitude to DPC and the organizers, because now, today, I'm doing my 375th presentation. This is the 25th country I'm speaking at, and it wouldn't have been possible without DPC. So thank you very much to everyone involved. I just had to put that out there. And if you are someone who has been part of this community for a while, it's a very welcoming community. And if you believe that you have something to say and you want to be part of this and you want to stand on stage here, there is a formula to it. There is a little bit of work to it. And I do recommend, if you know people who are speakers, approach them, ask them for tips. They'll be more than happy to help you. Now, I'm going to give you my most annoying slide first. Let's see how this works. There we go. Yeah, they told me to use dark colors. They told me that. So here we go. Oh, take the load off, right? I remember speaking here at WebDevCon a while ago, and I didn't take that advice into account. It was like white slides, and I saw people squinting and hurting their eyes, and I spent my Tuesday revamping my slides and turning them into something that fits dark mode a bit more. Before we can get started, there's a lot of people in the room, which I appreciate, and more are coming in. So, hey, welcome, take a seat. There's some front row seats where you can fall asleep if you want to. I won't be offended. But I present 3 distinct statements every time I talk about caching. And I want to use those statements to see if we're all on the same page. So let's try it. Ladies and gentlemen, here at Pathé Noord in Amsterdam, do we agree that slow websites suck? Is that something we can relate to? Great. All right. Let's do number 2. Do we agree that web performance is an essential part of the user experience? Yeah, right. It's a competitive landscape. If your website is slow, people will just go elsewhere and do business there. So 2 out of 2. Great. In my experience, that's the way it's supposed to go. The third one is slightly more controversial, and in my experience, opinions vary. So here we go. Do we agree that slow websites are just as bad as websites that are down? Yeah, meh, no, yes. The consensus that I noticed is it's meh. It's like yes, no, maybe. But here's a little something you might not know, and it doesn't keep your opinion into account. If your website is slow or down, you will lose money. You will lose face. You might lose a little bit of Google PageRank. Possibility. So how do we approach it? How do we make things better? Well, a lot of people look at it symptomatically and correlate the issue to capacity. Oh, our website is slow. It must be related to a lack of capacity. Let's throw servers at the problem, right? Not really. It does work in a short-term basis. When the house is on fire and you need to do firefighting, this is acceptable because you need to stay up and running, you need to stay afloat. But in the long run, you're just throwing money at the problems. And as the famous poet Notorious B.I.G. once said, mo money, mo servers, mo problems. So it is not the ideal solution, right? So in my experience as a speaker, I know that I have to pause now until that picture is taken. I know. So I'm going to give it 5 more seconds while the cameraman is nicely panning in on me. And we will find an alternative solution. So throwing money at the problem is not the real way. So what you could do, it's a very sensible thing, if you will, is identify the slowest parts and optimize accordingly. And there's tons of measurement tools in our ecosystem. I think Derek just did one on XDebug, and there's a ton of tools within our community and outside. It's a very sensible thing. Do it. Top down, bottom up, whether you're looking at the backend code or how you configured your servers in the data center or how you optimized the image and did some JavaScript optimization. Problem with that is, in the beginning, you'll have lots of gains, but after a while, you'll hit the point of diminishing returns where the amount of money you invest in making this faster won't yield the same results over time. You hit the limits, the dead end, because you can't optimize your way out of a scalability problem. And that's where caching comes into play, ladies and gentlemen. Caching, love using boxes as a metaphor. It's storing pre-computed results in a box for later use so that you don't have to recompute it again. Because why recompute it if the data doesn't change? And here's where we get a little bit more philosophical about the matter. We all know PHP. Everyone's involved in PHP here. By show of hands, I need overwhelming show of hands. Yes, we know our web server. We know what runtime we use. Most of us use PHP FPM. There's databases connected to it, services connected to it. And ingesting a request on the web server, passing it through your PHP runtime, bootstrapping your PHP modules, running your framework, doing all the business logic, connecting to the databases, doing those really expensive joins and group bys, only to return something that doesn't change every single time. So please, ladies and gentlemen, adopt a caching state of mind. And that being said, hi everyone, my name is Thijs. Good to have you here in such large numbers. It's actually refreshing to be in a Dutch-speaking country where I don't need to justify and explain my name. Try this abroad. Are there other people who have an I and a J in their name? It's the worst, right? Thijs, yeah, it doesn't help. But I'm happy to be here. I'm the technical evangelist at Varnish Software. I know it's a lot. The job title's a lot, and the picture certainly doesn't help. But I do a lot of outreach. I do a ton of presentations. I create content, video content, textual content, tutorials, all that stuff. And I also write books. So this is me, not as excited as I should be with my first book, getting started with Varnish Cache. Tremendous honor writing it for O'Reilly, but it's an old book. So what are you going to do? I still get royalties for it, but don't buy it. Get this one instead. Varnish 6 by example. My magnus opus, wrote it during the COVID pandemics, and it was a big one. It's a long one. The pandemics were long. I come bearing gifts. I have a free copy of the book, 778 pager, 2 kilograms. Get your workout on. I'm going to put it here, and I'm going to walk out the room in about 40 minutes. I'm not taking that back. So either you take it or someone else is going to grab it and throw it in the bin. I have other gifts as well, specifically reserved for people in the front rows who are brave enough. I come bearing socks. Socks are the new T-shirts, ladies and gentlemen. And I didn't plan this, but we have the exact amount of socks for the front row. So that's pretty brilliant. All right, I work for Varnish Software. By show of hands, who's heard of that company before? I need to block out this one. Yes, great. For the rest, welcome. There's room for improvement. We are a company that builds software-defined web acceleration and content delivery solutions with a very strong emphasis on software-defined. You can install us wherever you want, be that on your own hardware, with a hosting provider, in the cloud, using Docker images, or orchestrated in Kubernetes clusters. It's freedom of infrastructure, freedom of architecture. Do with it what you want. So here's a typical interaction pattern between a user and a server. It's a direct one. And under normal circumstances, there's no real issue with this. But of course, when you start hammering things out, when there's tons of concurrency or maybe computationally heavy requests, the server may end up under pressure. It's also something most of us can relate to, right? Performance, scalability, it's a thing. Now, the way we position ourselves as a cache is as a reverse caching proxy. We position ourselves in between the user and the server and act on behalf of the server. We receive all the requests from the user, and as such, by storing responses from the server in the cache, we alleviate a ton of pressure from the server and can make applications go faster. So that's very much a quality of service kind of characteristic. Of course, by storing it in the cache and delivering it at super high speed to the users, regardless of the traffic patterns, we also lower network latency, which is a quality of experience characteristic. So it depends on how close you put the caches to the user and how close you put the caches to the server. But of course, today it's about PHP applications that we'll try to improve, and the goal is to improve the caching. That could be done by fiddling about on the caching server itself, but it could also be done at the application level, which is my preferred way of doing it, because it adds a level of portability, and we can speak about developer empowerment. And there's tons of caches. Like if you look at computer systems, it's turtles all the way down. But we will restrict ourselves to HTTP-based caching because the HTTP protocol we all know and love has built-in caching mechanisms that are quite conventional, such as this, folks. Hash control public max age equals 500. Who's seen this before? This is easy for me to watch because it's a dark slide. I can actually see your hands, and that's good. Let's try another one. How long will the reverse caching proxy cache this, ladies and gentlemen? You have a voice, use it. It's a trick question. Everyone does that. I know, I'm sorry, I didn't want to trap you, but it's not 500. Now, of course, there's different variations of the directives in the cache control header. Max age is a pretty generalistic one that both shared caches and clients can use, and it defines a TTL. But there's a dedicated one called S-max age. S stands for shared. That means shared devices, not private devices like clients, are allowed to cache it. Of course, we all know the expression, there's only two hard things in computer science, and it is naming things and cache invalidation. I won't be talking about cache invalidation, but the naming things is pretty damn obvious, right? Max-age, S-max age. It could have done a better job. But long story short, the cache will cache for an hour, and the browser is free to add another 500 seconds to it. Let's try this one. Who's seen this one before? Stale while revalidate. Well, for those of you who don't know, stale while revalidate, the name already implies a bit. Keep serving stale data if the content expires while we are asynchronously revalidating the content. It is a way of not making the user the victim of a cache miss. So if something has expired, because it expires after an hour, you have 100 seconds past the point of expiration where you can keep serving old content while we get the new stuff. It's a way of doing things a lot more efficiently. And we all know this one, private, no cache, no store. Yes, there's different reasons why you would use either of those. And yeah, private means only clients can cache it, not shared caches. No cache doesn't mean you can't cache it, but you can't serve it from the cache without proper revalidation. And no store means don't store it in the cache. And the good thing about all of this and all of these headers is that Varnish applies these best practices. It complies to those conventions, which makes it very easy when you have to cache a static HTML page or imagery, JavaScript, CSS, no problem whatsoever. But it does get rather interesting, and the color's getting bright again here. I'm getting it right in my face. It's my own fault. Varnish, and here's an interesting statement, Varnish does not cache out of the box when cookies are used. Let that sink in, right? Or Varnish doesn't cache when it sees an authorization header. Now, just for fun and giggles, who uses websites or sees websites on a daily basis that don't use cookies? I'm expecting no hands, indeed. So is the logical conclusion then that Varnish can't be used in the real world? Obviously not. Of course, out of the box, we need to take a defensive approach. Because if you cache something that uses cookies or an authorization header, the implications are that it's probably private content for your eyes only. It shouldn't end up in a cache. And there's enough horror stories out there of people caching things they weren't supposed to be caching, and now everyone sees it. So we're a bit defensive. However, thanks to the built-in VCL, VCL is short for Varnish Configuration Language. It is a domain-specific language. Within Varnish, we can tweak the behavior of the cache to the exact needs of the application. And this is not a top-down programming language. This domain-specific language that has a curly braces style is used to extend a standard behavior that is very conventional and that is represented here in this flowchart. Can I assume, just to be on the safe side, that it's not too much to ask for you to read and interpret a flowchart? Is that a skill I can assume everyone possesses? So we have the different stages in the execution flow. Every box you see here that is named VCL_something represents a state in the execution flow which has a standard behavior and that can be extended. And in each of these boxes, you do a certain amount of behavior and then you do a return statement. And the return allows you to transition to the next state. And you can see that if you follow the arrows, you see the keyword that is used representing the action, the return statement. So let me give you two flows that we will go through. You start at the top left-hand side, and you enter VCL_v, which is short for receive. You receive a request, we check whether or not it is cacheable, and when it is deemed cacheable, we return hash to create a caching hash. And the host header and the URL is used, the hash key is composed, we're looking it up in the cache, and then it's either a hit, or a miss, or a bypass, or anything else. Let's assume it's a miss. A miss isn't the worst thing in the world, a miss is just a hit that didn't happen yet. Eventually, it'll become a hit. So you follow the blue path and end up in this box here right in the middle. And this box represents communication with your PHP application by doing a fetch, by getting the response, by storing the response in the cache, and then delivering it. And then obviously, when you do it one more time, you go from start to VCL receive to VCL hash, you follow the green line, hit, deliver, done. And that's pretty much it. And here's some initial VCL code where you extend the standard behavior. Of course, you need to define where your application is going to live. I did the poor man's option here by hosting it on the same machine on port 8080. And then we hook into VCL receive. Remember that I told you that Varnish doesn't cache when cookies are there? Well, we're bypassing that logic. We're entering VCL receive, we're doing an if statement, and checking whether the URL of the request matches a regular expression. Please spot the tilde, that's an operator for regular expressions in the VCL language. So if the URL starts with admin, or /admin/, or a subordinate resource of admin, we are obviously in the admin pages, we'll need cookies, it's highly personalized, we won't cache, so we do return pass. And return pass here follows the red line. These are things that will never end up in cache. So that's a safe way of doing it. And under all other circumstances, we know we don't need the cookies, so we remove them. And this includes any type of tracking cookie that might be used by a JavaScript library like a Google Analytics or a HubSpot or whatever you use. It's safe to remove those. And in that way, only the admin pages will result in cache misses, all the rest will be cache hits. And that cookie story you can also approach not from a URL-centric perspective, but from a cookie-centric perspective, where you check whether a cookie is set, you load a module that parses the cookie request header, and then just says, remove every cookie, but keep the PHP session ID cookie. Because we know PHP session ID is not just a way of categorizing or segmenting content, it's pretty much a way to identify a user. So if you're logged in, we're assuming that all the content is personalized, we won't cache. But if after this find and replace, we end up with a collection of white space characters, there's no cookies left. We can remove them, fall back to standard behavior because we didn't do a return statement, and things will be cached. And my message for you, while this is fantastic and allows total customization of the caching behavior, my advice is less VCL, more headers. I want to trigger you to be more empowered as a developer and write applications that have caching in mind and are very portable. So if you are a customer of a CDN and you become a Varnish customer, you don't need to change anything, and vice versa. And we're going to do that in PHP through a Symfony application. I'm more of a Symfony kind of guy, but a lot of the things I'm showing you are perfectly compatible with Laravel. And I have 5 chapters, 5 things we're going to do, and I put them in bright white. Every chapter is bright white. Number 1, cache control. Let's go back into dark mode. So remember 100 seconds of max age, an hour of SMax age. How we're going to define that? Well, it's pretty straightforward, right? We're bolting it on in the execution flow, and we're not overhauling all our code. So Symfony has these nice methods when you render a Twig template to set public content, to set the max age, set it to share max age. You can do that in a hard-coded way, as I'm doing now, or you can involve a database or an external service to get the TTLs out of there. It's pretty straightforward, doesn't require a lot of adaptations of your code, doesn't require any overhauling. Let's say something cannot be cached and you want to do private, no cache, no store. Well, that's going to result in this one. You can set private. You can't chain the add cache control to it, apparently, so you have to get the response headers and add the cache control directives to be good to go. That is the simplest thing I'm going to talk about. I think it makes sense. I'm assuming you understand what it means and how you can trigger caching behavior. But let's dive a bit deeper and talk about number 2. Yes, I'm so happy I did dark mode. Asynchronous revalidation. I hinted towards it in the beginning. Thanks to that stale while revalidate directive, you can actually trigger the cache even if your object has expired to keep serving the old stuff while we do an asynchronous fetch, which ensures that the user gets very quick responses and eventually will get the updated content. So you've seen this, stale while revalidate, 7,200 seconds. Yes, the Symfony framework, in the same way, has a way of chaining that on. So please think of the content that has a level of tolerated staleness. Now, I was at a Magento conference in the US a couple of weeks ago, and there was guys selling gold online. And they wanted the most recent prices of gold. So any staleness for them goes out the window. So if you do real-time stuff, and it's important to you, set this to 0. Or set it in VCL. You can set it in VCL to 0 as well. But if it's for regular content, it's just mentally you're readjusting what real-time content means. If that is important for you, a lot of people, especially also in the e-commerce space, really rely on stale revalidation to ensure that if there is a surge of cache invalidations, that we can keep serving the old stuff. Because the total lifetime of an object in the cache, and I think I need to give you that glimpse under the hood, is the sum of the TTL, the grace value, and the keep value. Now, these sound abstract maybe at this point, but allow me to expand on that. The TTL, if you set it based on cache control or the expires header, or you set it in VCL itself, it is that value. If you don't set anything, we will default to 2 minutes. So that's your normal lifetime. If this is a moving target, in this case, you start at 2 minutes and it just goes down every second. And as long as it's not 0, you have fresh content that will be served from the cache. But when it hits 0, then you have to rely on grace. And grace is our implementation of stale while revalidate. If you don't set it, it's 10 seconds. You can override it in VCL, or you can do it with stale while revalidate, as I've shown you. And then keep is rather obscure. It just keeps the object around for later use for synchronous validation. And I'll show you an example. Let's do a use case. If your TTL is 100, you're pretty safe, so you can do a cache hit. No problem. When it hits 0, it is expired and is in need of revalidation. You need to do a fetch. But because there is 10 seconds of grace, we can do that in a stale way. Even if it's at -8, the sum is still greater than 0, you are good to go. Async revalidation. But then it hits -11 plus 10, slower than 0. There's no keep. You have to do it's a proper cache miss. The content will be evicted from the cache. The user has to wait. So it is expired and out of grace. But if you set the keep value, which can't be set in HTTP, it's pure VCL, if you set that, we will keep the object around for 100 seconds, allowing you to do synchronous revalidation, which doesn't sound that great, but conditional synchronous revalidation. And that brings us to chapter number 3, the aspect of conditional requests. And conditional requests revolve around that idea that you only fetch content that actually changed during the revalidation process. And it's significant. Typically, when you revalidate, which means either the client or the cache sends a request to your application, you'll get a 200 OK, and life is good, and you get the payload, and you rearm the cache, and you reset the TTL, and you're good to go. But there is a better way. In a conditional way, you can check whether or not it has changed, and if it hasn't changed, you'll get a 304 not modified. Now, knowing that the status code starts with a 3, you know that there's no payload. So the advantage of that is that it's a lot less data over the wire. Because pretty much it's the server saying, whatever you have in the cache, it's still good. So keep doing it. And here's your new cache control header. Go along. So huge amounts of bandwidth could be reduced on that. Now, how do you know if it's changed or not? Luckily, HTTP has got your back. So an E tag or an entity tag can be used to emit this sort of fingerprint, if you will, of what the content is like for that resource. I typically just throw in an MD5 hash or a SHA hash of your content. It's a good fingerprint. Then what your browser does behind the scenes, maybe other HTTP clients do it as well, is they take the E tag, and the next time they go for that resource, they throw in the if none match header and say, hey, if last time I checked, this was the fingerprint, is it still the same? And if it is the same, as you can see, it ends with 27, it starts with 7C, 304 not modified, end of story, and the execution, which is a great improvement and allows for lower resource consumption. Initially, bandwidth. It's not purely based on a fingerprint. You can also use modification dates. There is this header called the last modified header. You can return that as an application, and then your client will be clever enough, like the typical browsers do it, the Chromes and the Firefox and what have you, they will return an if modified since header, and then you can do 304 not modified. Now here's the important bit, and here's where we're going to go. I want to tap into your developer brain, and that's where the slides are going to get white again. Please, ladies and gentlemen, leverage this. Yeah, are you ready? Here we go. Please validate quickly. I'll repeat, validate your E tags and your last modifieds as soon as you can in your framework and exit early. Right? Maybe not. I'll show you how that works. So here's a little bit of code, an event listener that I built in Symfony. It's an E tag listener. Because it's an event listener, you could just bolt it on without having to redo your code. So what this will do, I already spoil it a bit, it will hook into the request flow, try to get your request in as quickly as possible, fetch the if none match header, match it to a key value store where you store your E tags, match it, do a 304 not modified as quickly as possible, return from the execution flow, and not run your business logic if the E tag's the same. So all of a sudden, you're not only saving up on bandwidth, you're saving up on potential memory, CPU cycles, disk I/O, and other stuff. So how does it work? Well, initially, you need to load a caching interface as a dependency, and that will pretty much auto-wire. Please don't confuse this with HTTP caching. It has nothing to do with it. It's a built-in key value store. Symfony has many adapters. Could be Redis, could be just APCU, whatever. We just need a quick access mechanism that doesn't require looping through all the code or accessing expensive databases to know what the actual latest E tag was. So we'll store it there. And then we carry on and do an on-kernel request, which we wire like this with this annotation. And the next thing we do is we pass the event, the request event, as a dependency. And then we can get the E tag data out of our key value store by maybe, this is just my way of doing things. This is not production-ready code, by the way. This is just proof of concept. I use an E tag prefix. I MD5 hash my URL. I look it up in the cache. And if it's not null, that means we did find an E tag here. And then we extracted. It's an array. The first key is the E tag. The second key is the cache control header. And then we create a new response rather than waiting for the response to be dispatched. Create a new one. We set the E tag. If the CC, the cache control header, is not null, we add the cache control header. And here's the little magic that Symfony does under the hood. There is this response is not modified method. You throw in your original request. In the response, we already loaded the E tag. It does the comparisons itself. And it will even set the not modified response status. And if it's not modified, just set the response, execute, and the rest won't happen. Now, a little caveat here. There's only two hard things in IT, right? Naming things, cache invalidation. Please invalidate that key value store when you do content changes, because otherwise you might serve content that is too stale. Keep that in mind. But also, you need to fill up the cache again, and that happens at the response side of things. So when you render a response that goes through the entire execution flow, again, annotate it, load the response event, and please check if it's not the not modified one, otherwise you just end up in a loop. So you want to avoid that. So the next thing we do is we create the E tag by doing, in my case, a very simplistic MD5 hash of the content, and we extract the cache control header, and then check if it's not modified. So if it has modified, store it in the cache for an hour in this case. After an hour it expires, good to go. So of course, there's many adaptations of this, and I recommend making this suitable for your application using more mature coding practices. But my advice is leverage the 304 not modified header, leverage the E tag and if none match, leverage the last modified and if modified since header, and let me know if your resources consumption drops. Right, number 4. This is so fun seeing you squint. I'm having so much fun here. Content composition. So we all know that an HTTP response is a single thing that happens, right? It's something atomic. There's a response, and whatever is there is there. Of course, some of the content blocks differ in terms of their cacheability. We all know that the header widget might have a login that says, "Hi, Thijs," and that probably uses a cookie and is not cacheable. And the largest common denominator here, because it is a single response, is not to cache it, which is a bit of a problem. So how do we approach it? Well, there's the use of placeholders. There's plenty types of placeholder that you use to separate cacheable from non-cacheable content, and they usually involve splitting it up into multiple HTTP requests to do the job. So, ladies and gentlemen, I'm going to need your help again. In your arsenal of tools, if we go back to the legacy, the oldest thing we can think of, the dinosaur of placeholders, what could we use? Jill said an iframe. This is my next slide. An iframe. The dinosaur technology, but still does the job. But the problem with that kind of thing is, does this happen on the server side or the client side? Client. So all of a sudden, you've turned your problems into user problems. They're like, dear user, we have a cacheability issue, and this is not cacheable, so you have to do 2 round trips. That's all good on broadband, but if you're on a shitty 3G connection, good luck with that. Okay, let's stay in the world of client side a bit more modern. What other piece of technology do we have to load it separately? Don't call it Ajax. We're in Amsterdam. Call it Ajax. Yes, of course. I had to throw that one in. Ajax, indeed, this asynchronous access, a bit more resilient than what iframes can do because there's graceful degradation. If it fails, you could deal with it. But still, you're turning it into the user's problems. Anyone have another idea? Come again? Let's go to the next slide and see what happens. Edge side includes. Thank you very much for your contribution. Now, for those of you who don't know edge side includes, who here is old enough to remember server side includes? And I'm going to, oh yeah. I apologize, you are exposing your age here. You are, and I'm not outing you. You're doing this to yourself. So server-side includes, for those of you who don't know, were XHTML style-alike tags you can drop into your HTML content without having a server runtime like PHP or anything else, and you expect the web server to replace it with whatever content is there. It is a server-side include. It means your web server will process this. Edge-side includes do the same thing, but on the edge. And the edge is a buzzword we like to use in our business because it means the outer tier of your web platform. It's typically the CDNs, the caches. It's anything that accesses the users directly. And it could be thousands of miles away from your server. It could be, specifically if you use Varnish technology to build your own CDN, it could be somewhere in the United States where your origin server is here in Amsterdam. And this is what an ESI include looks like. It's XHTML style. It's a placeholder. You drop it in your HTML code or your API, JSON output, whatever, and that header endpoint will be loaded by Varnish, not by your PHP application. PHP application typically has very little awareness. Now, the benefits of it is it's very simple. It's standardized. We didn't invent it. Akamai invented it. It's in the W3C standards. It is parsed by Varnish, which is nice. And it allows you to make the output of your application a composition of blocks. And you're not turning it into the user's problems because it's the server that processes it. The user is none the wiser. They get a single response. And it allows you to give a state per block and a TTL per block. So imagine this being your HTML code. And I want to render my username in there because I have a session cookie that does that. So Varnish will turn this into that. And here's how it does that from an HTTP perspective. So we start by sending a request. Our client sends a regular request to Varnish. Varnish says, damn it, cache miss, we need to fetch it. But we will add, here's the magic keyword, a surrogate capability header. And it says, hey, I can act on behalf of you, and I can do certain things. And one of the capabilities I have is ESI parsing. So if you're up for it, let me know. I'll parse those ESI tags for you. And the application, the PHP application responds and says, great, thanks. Allow me to cache this page for an hour. And by the way, you have surrogate capabilities? I'll take surrogate control. So I do ESI as well. I support it. So rock and roll. And Varnish says, great. I spotted in your page, I spotted this header endpoint as a source attribute in the ESI tag. So fetch that. And it says, thank you, and serves it. And in the end, it's a single response to the client. The client is not aware of it. So server response is this, again. Edge response is that. And it requires a little bit of VCL tuning, because we don't parse ESI tags out of the box, because that means we have to scrape every single piece of textual content to find it, which might be a little bit CPU heavy at times. So this is the negotiation code you've seen earlier. When we do a fetch, in VCL backend fetch, we add this custom surrogate capability header and add the key equals ESI 1.0. The name key could be another name. You could call it Varnish, or you can be multiple caches deep, and each cache has its own capabilities, and you can do targeting to that. But this is just to announce it to the application. When the response comes back, we check whether there is a surrogate control header, and if it contains ESI. And if it does, we strip off that header because the user doesn't need it, and we enable ESI filtering. And the upside of doing something like that in Symfony is that you can do composition at the view layer. It doesn't require overhauling your business logic or your application, but you should then create a route per fragment, per block. You have your regular homepage, cacheable in this case for 60 seconds. It's not a lot. Could have done better, could have done more. And then, of course, we have the private content in the header. The header cannot be cached. So this and that, which results into the following Twig template. In Twig, you can switch from maybe in your main layout just including these Twig files to rendering the endpoints that they refer to. So you can call the render ESI function in Twig, do a URL call on the named route header, and parse it in. And it will happen automatically. Everything will happen automatically. The render ESI function will check the surrogate capability header, it will return the surrogate control header, it will emit the ESI tag, it will do all those things. And if the surrogate capability header isn't there, or doesn't match the right value, it will fall back on internal rendering within the Symfony engine. So it's perfectly safe with or without a Varnish or a CDN or anything else in front of it. All right, last one. Number 5. Before I send you home. I see that, yes. I have 10 more minutes. I hope to do it in 5. Cache variations. It's the last piece of the puzzle. And the question I would like to ask you is, how do you identify an object in the cache? And I won't go through the pleasantries and asking you, and then you have to respond. We've already done it. We know the answer. It's the host header plus the URI. Compose those, put them together. I mean, URI is the unique identifier of the resource, and the host header was added in HTTP 1.1 to do virtual hosting, where you could serve multiple websites on a single server. Great, you put them together, do a hash key, look it up, hit or miss. But what if the content represented by a URL varies based on a request header? I'm going to give you a very concrete example. Multilingual websites that leverage the browser language. Now, the browser uses an accept language header. Your browser does that automatically to state which languages it supports and in which order. Now, of course, if you have multilingual content based on that, knowing that caching is a first-come, first-served business, I am Dutch-speaking, I will go to the website, alles is in het Nederlands, you throw it in there, I see this nice Dutch content, and then there's this French guy who doesn't understand it, gets frustrated, and that's the end of that. So luckily, you would solve this in this way. You would emit a vary response header, and the spec of these vary response headers is that they only accept valid HTTP request headers. So in this case, it says, "Dear cache, please vary based on the accept language." And this is how it looks more schematically. So this is me. My accept language is NL. I speak Dutch, I go to the content, I want to go for example.com/, it's a cache miss, it returns it and says, "Vary accept language, please." And then the cache, knowing that you have the host header and the URL, creates a Dutch variant and an English variant. And you are safe, or at least you think you're safe. Because what you need to do is you need to clean up those headers. Because this was my browser language in Firefox. In my Chrome, it's all English, for the sake of simplicity, but this is mine. So it's NL for some reason, not NLBE. I'm not sure what's wrong with my config. It's NL Q 0.9, but Varnish has no awareness of this. For Varnish, it's just one string. So if yours is NLBE, or it's NL first, and then French, and it just messes up the thing completely. So we need to sanitize that input. And luckily, we have a module for that. Then what we could do in the VCL init part, which I didn't show you in the flowchart, it's before requests come in, it's when Varnish starts. It loads these formatting filters, and we have a format object and a lang object. So what we're doing here is supporting text plain, text HTML, application JSON, and also text plain. The first one, except rule, is the fallback value. And that also applies to language. So we support English, French, Dutch, and German, but if you speak Spanish or Italian, we will fall back to English. Because you only need to put the languages in there that you actually support, because why do language variations on languages that aren't really supported? You try to minimize the cardinality of your caches to improve the hit rate. And then we just take the accept language header and just reduce it to something very simple. So in this case, it would reduce it to NL. That's all it is. And you'll do yourself a great favor with that. You can also chain them together, vary accept language, vary exforwarded proto. Who's heard of the exforwarded proto header? Very few people. Exforwarded proto is a header you use when you use multiple layers of caching or load balancing in front of it to identify what the original protocol was that was used when the request is sent. So if the initial request was an HTTPS request, the value of exforwarded proto will be HTTPS. And you do want to create a cache variant of it. Because imagine that you do HTTP to HTTPS redirection in your application, and you cache the 301 redirect to the HTTPS version. You store it in there, but by default, Varnish has no awareness of it. It knows the host header and the URI. So every time someone goes to that one, they'll be stuck in an infinite loop, and you really want to avoid that. So you want to make sure that certain elements in HTTPS are stored in separate cache keys than HTTP. Or you can write VCL for it that says if you have a 301, store the different variants. And this is how you would create this vary header in a non-intrusive way. You could, again, do an event listener and set the vary headers accordingly and be done with it. You can also put them in your business logic, but this is a bolt-on solution. And as a final piece of the puzzle, what if you can't leverage HTTP? Like, what if you're stuck in legacy world and you can't really touch all those headers, you can't really set them? Well, then